So for this given reaction, we know that the change in enthalpy is negative 563.3 kilojoules, and the change in entropy is negative 140.5 joules per Kelvin. And we want to find the standard free energy change in this reaction. And so what we need to do, we need to know the equation delta G naught is equal to delta H naught minus T times delta S naught. And since we want to find the standard free energy change in kilojoules, we would need to convert the delta S from joules into kilojoules. And so to do that, we just take negative 140.5 times 1 kilojoule over 1,000 joules, which equals negative 0.1405 kilojoules. And this is the number we want to use for our equation. And so now we need to plug everything into the equation. Delta G naught equals negative 563.3 kilojoules minus 255 Kelvin, that's the T, and then the delta S in kilojoules, so negative 0.1405 is equal to, let's see here, negative 527.5 kilojoules. And now we can't forget about the reaction for the moles of H2CO. This reaction calls for 2.36 moles, and the equation I just did was for 1 mole. So now what we need to do is take 2.36 mole of H2CO and multiply that by the amount we found earlier, negative 527.5 kilojoules of free energy change per every 1 mole of H2CO, and that would equal negative 1,240-ish kilojoules, and in scientific notation that would be 1.27, negative 1.27, sorry, negative 1.24 times 10 to the third kilojoules of free energy change. So negative 1.24 times 10 to the third kilojoules of free energy change. And then since this delta G is negative, this means this reaction will be product favored. Now, if this reaction's delta G was positive, it would be reactant favored. And that is the answer to this problem.